The campus here at UW-Seattle is so large that oftentimes students have no idea of the amazing research that's taking place. Such is the case with the Solheim Lab. This lab uses and develops printers that build objects using a process called Additive Manufacturing. Mark Ganter, one of the professors here, led us into his secret lab deep in the heart of the mechanical engineering building for this interview.
You're standing in the Solheim Lab. We have about 10 different additive manufacturing processes. We can print in a dozen kinds of plastic. We can print in about 20 kinds of ceramic. We can print in about 50 total kinds of powder, including metals. Any piece of geometry you can imagine, we can model. Additive manufacturing basically deposits thin layers of an object. So if you made a computer model of an object, it would be sliced into very thin layers. Then a process would build the object by producing each single layer at a time and then adding them up as a stack.
If you look at this, for the bottom cross section, you're just going to have a circle. For the next one, it's going to be a bigger circle. And then slowly, as you put all these cross sections together, you get an object. Hence additive manufacturing, adding it layer by layer. I was looking for a way to combine the analytical side with the artistic and creative side. And then I found Mark Ganter and got exposed to rapid prototyping and the ability to design something in 3 dimensions and then see your project come to fruition by the press of a button. There's always something new going on, whether it's trying out a new powder. The current powder we're messing around with is they're able to pour glass. It's a mold powder, so we can print out molds and then cast glass directly into the mold, which is something that nobody's really done before. So getting to create your own project, come in here and be creative while learning and doing some kind of research at the same time is a lot of fun.
This is probably my favorite piece that I've made. It's a Star Wars X-Wing. The assignment for this part was to create a moving assembly on the Stratasys Dimension 3D printer. So, well, of course, me and my partner love Star Wars, so we had to make something Star Wars related. So we made this X-Wing, and the cockpit lid moves up and down on a small hinge, and the wings also open and close. They pop open because they're spring-loaded and the latch just fits right in the side. We were given the limitation of only 3 cubic inches of material. This guy's a little bigger than that. And we wanted him to, really move and be very clearly visible, so we made it hollow and larger.
There's a project out of England, out of Bath, called RepRap. It's a self-replicating prototyping machine, and to date we've produced about 3 or 4 in this lab. One of the individuals has actually produced 14 more, so we're trying to breed them.
All the red pieces were built on the Stratasys, and then what the machine does is it can print all of these pieces again. So a piece breaks or you want to make another machine, you just print it on this one.
The green material that's printing is PLA, which is polylactic acid. It's corn plastic, and it's that same material that we all know and love in the forests that don't work very well. The kind that the dining halls have that melt in your soup or melt on your hot pasta.
So where does Mark Ganter think that this technology is going?
I want a Star Trek replicator. Everybody does. We'll get there.
That's what we're working on. Basically, we want to make one that's the size of your HP or LaserJet printer.
So we think you can build them for $350. The fact that it has the possibility to actually change everybody's lives. To have a machine like one of these RepRap Mendels at your house and being able to produce things out of a variety of materials that you get to choose, that's pretty cool. It's just crazy.
Want to know more about Mark Ganter, his students, and this world-changing technology? Head over to their blog at open3dp.me.washington.edu.